we pretty much, except for graphing, this whole chapter has been getting us ready to solve log equations. And so today we're going to solve all types of log equations. Tomorrow we're probably going to look more at exponential stuff and look at some word problems and solving them, doing that. This is the last section of the unit, of the chapter, of the year. This is the last section. So 6-6. 6-6, day 1. Just a little reminder that Friday, the Ivy Tech math guy is going to be here observing, so maybe we shouldn't spend 10 minutes talking about dum-dums and, try to actually act like we're a college class, not eating dum-dums every day. These are just a review of all the properties that I've given you. You have these in your notes already, but if you want to have something to go to today as some reminders, you're welcome to write them down again or not. I don't care. But this is the definition of a logarithm. If you see a log equation, remember that you can always rewrite it, where this is the base, the answer is your exponent, and this is the problem worked out. So y equals log a of x is the same as saying x equals a to the y. And sometimes you can solve an equation by just rewriting it, and we did some of that already before break, but we kind of forget. And then these are just some overall properties, definitions, rules that you should know. Remember that if you have one log equal to one log and they have the same base, then you can just set m equal to n, which is a super great way to solve an equation. And also remember that logs and exponentials are inverses of each other, which are these 4 properties, which again we wrote down already. But if you have log a of a to the x, then those just cancel out and you get x back. If you have a to log a of x, you just get x back. E and ln are inverses, so e to the ln of x is x, and ln of e to the x is also x. And those are the properties that we're going to use. Sorry.
Like it's in there, but it's not a jelly bean. I was expecting like a full jelly bean, but it's just like squished stuff in the middle.
Sorry, I haven't eaten one. Parker's eaten one. I'm okay with it. Parker comes in every day. This is the snack bag, and it's just full of snacks. And every day Parker passes up the apple, he passes up the banana.
Oh, the banana looks like a banana.
He's been there a couple days. He passes up the granola bar, and he goes for the dum-dum, and the eggs, and the airheads, and the granola bar. He passes up all the good snacks I bring, and only finds the candy that's in there. Then they're all brown and awful. Like when bananas get cold, they turn brown. So.
No, it's still good. Why open it? The inside was disgusting.
Miss Blackman always said when her bananas got too ripe, she just put them in a bag and put them in the freezer, and then she'd make banana bread. But I just couldn't imagine how gross they would get. But because you freeze them first, or if they're rotten, yeah. And you freeze them. I've never frozen them. I should try that. So.
I know.
It's pretty yummy. I'll eat that banana today. It's only been in there since Monday. Well, Sunday night. It's only Wednesday. It is a while. No one's eating bananas now, so I have to keep bananas in my house because he'll actually eat them. The hard part about these is there's just so many different ways to solve them, and you just have to look at them and think what you could do. Anyone have an idea of what we could do? Could I put this 2 back in here as an exponent? So that would be log 5 of x squared equals log 5 of 9. And then, since it's 1 log equals 1 log and they have the same base, can we just forget about the logs and say x squared equals 9? Then how would you solve that? So we're going to both sides, and we get x equals plus or minus 3. But, remember, logarithms are very restricted domain. You cannot take the log of 0, you cannot take the log of a negative number, right? So you have to look at your answers and make sure that when you plug it in, it's not going to take the log of a negative number. Is plus or minus 3 both going to work in our problem? That's going to be log 5 of negative 3. You can't take the log of a negative number, so you have to say that -3 is extraneous, and the only answer there would be 3. Great for you, because most people forget to put plus or minus anyway, so you just luck out. But you have to check all your answers, like not necessarily work it all out, but just make sure when you plug it in that you don't get a negative log. Remember, you can't do this on your calculator unless you have a fancy calculator, because our calculators only have log 10, right? Not log 5. Ooh, what about this one? Parker's very upset, Megan, that Miss Whistler is still not coming back. I'm worried she's never going to come back. She had a car accident before break. Yeah, her and her husband were in a car accident. She broke some ribs. Yeah.
Oh, like old Miss Whistler.
Mrs. Whistler, yeah. Yeah. Right?
Parker's kindergarten teacher.
She's a kindergarten teacher. She's one of the kindergarten teachers up at Central, but she was a kindergarten teacher at Reelsville. Yeah, yeah. She was Megan's kindergarten teacher, so yes.
You know why I really do think that she's
I was gonna say, I was thinking that you were talking about her daughter.
There's a kid in Parker's class, and on the field trip I learned that his mom had Mrs. Whistler as a teacher also, so she's been around a while. So she's probably going to retire soon, I would think.
my mom had this.
Any ideas on this one? You can't make the logarithms go away pretty much if you have two logs added together. So this is where our properties come into play. When we see addition of logs, what do we know we can do? Multiply them. So the first step on this one would be to say that this is log 5 of x plus 6 times x plus 2. Yes? And you will FOIL that out in a minute. You have two options on this. I don't care which way you do this, it's just whichever way makes most sense to you. One way you can do this problem, and the way I think the book does it in their examples, is they use the definition of logarithm. Although there's x's in this, we could rewrite this and say this is the same as saying 5 to the first equals this, right? That's the definition of logarithm. So you can rewrite this and say that this is 5 to the first power equals x plus 6 times x plus 2, and then you can FOIL that out, and we got to solve that still. Before you start FOILing, I want to show you the other way, and then you can kind of decide what way you think to do it. The other way to do this is, let's say you don't want to think about that, we could undo log 5. What is the inverse of logarithms? Exponential, right? So if this was an ln, how would we get rid of ln? We would e both sides, right? We did that already. If I want to get rid of log base 5, instead of eing both sides, I can 5 both sides. It feels wrong to say that, but I don't know what else to say. But just like you can e both sides, you could make both of these like 5 both sides, where what is there becomes an exponent. And I just want you to realize you get the same answer, because 5 log 5 cancels out, and you're left with this. And what do you get over here? 5 to the first, which is what we have here. It's the exact same thing. I just don't like to keep things from you and say that this is the only way to do it is to rewrite it. If you like lning things and eing things, you can also 5 things. And plus it's fun to say I 5 both sides. Okay. I don't care which way you do it. I'll keep doing it both ways. I just want to show you that. The big thing on this is now to actually solve it, we're going to FOIL this out. That's going to be x squared plus 2x plus 6x, and then plus 12. That's a quadratic, which means what should be my next step to do? Move that 5 over. If you like to get quadratic equal to 0. If Vaughn were here, he would tell us that he would complete the square here. Plus 7. But I'm going to just try to factor that. But remember to get it equal to 0 before you factor it. Well, multiply to give me 7 and add to give me 8 plus 7 and plus 1. Are you with me on that? Which means I think we get two answers here, -1 and -7. But remember, you have to make sure you're not going to get a negative in your log. So don't automatically throw both of these out because they're negative, but you do need to make sure when you plug them back in that you're not going to get a negative up here. So what about -1? If I plug in -1 up here, is that going to be okay? If I plug in -1 right here, is that going to be okay? So -1's good. What about -7? Not good because -7 plus 6 and -7 plus 2, both of those are negative. So you have to throw out anything that would give you a negative log. So definitely the factoring stuff is going to come back into play, but hopefully it won't be too bad. I don't think there should be any like quadratic formula stuff. How do you feel about that? Let's do some more. I think I only have 3 or 4 of these, so good thing since we wasted so much time today. Oh, like 3 or 4 total, I think.
You can always tell when there's going to be an easy lesson because you're like way more laid back.
I feel like I'm just laid back in here every day anymore. I don't even know. It's out of control. We're just almost done. Like this is our last lesson. Like I don't even know what we're gonna do after we take the final exam. And it's April 2nd. It's a little stressful. Same idea as the last one. You can't get rid of LNs if they're added and subtracted. So that's why the properties that we learned in 6.5 are so important. Subtraction goes back together as what? Division. So this is the same as saying ln of x plus 6 divided by x minus 4. And then again, I guess we have 2 options here. One option is you could e both sides because e is going to get rid of both those ln's. But just like logs, if you have log equal to log, you just cancel out the logs. Same thing with ln's. If you have ln of something equals ln of something, then those somethings have to equal each other. So that means we could just say that x equals x plus 6 over x minus 4. Now the hard part is, do you know how to solve that? So multiply both sides by the denominator here. How did you get so smart, Nathan? Probably that awesome algebra 2 teacher you had.
I thought it was. I was so hot that year. There was no way out of my class.
There was. Will Honeycutt got an A on his major C test, I have to say.
Didn't he end up dropping that
He
class?
ended up dropping out of school, I think. But
No, that was Chris.
that was Chris. Chris got a B on a test. Chris got a B on that major C test, and Will got an A.
Chris.
Yeah, there's a lot in our class, but dude,
I thought it was only 4.
What do you do now?
Okay, that's cool.
well, I don't know what you do once you have a kid. Soon you have to provide for it.
This is another quadratic, which means I'm going to subtract x over, and I'm going to subtract 6 over, and I'm going to get x squared minus 5x minus 6 equals 0. You are welcome to do the quadratic formula or complete the square at any point, but these should be factorable, I believe. What? Okay. Are there even 100? Are there 100 kids? I thought there was less than 100.
I think we were like at 98.
So that's more than 6%.
Oh, actually, there technically is like 7 people in our class. There's 2 people are like the boy and the girl are both in our class.
That's true.
Let's stop talking about teenage pregnancy, please.
We're not naming names.
Hey, now we need to put the other kind of schools too.
I haven't done that, but well, maybe we'll do something like green test. They're spread out.
I'll never forget maybe I don't know, maybe 2 years ago. 2 years ago, there was someone that was pregnant, and I said that my mom had my sister when she was 16, and that it was really hard to have a kid when you're 16 back in the 80s. And they said, "Oh, it was be so much more accepted back then." And I said, "No, it wasn't. You guys are all like giggly and planning baby showers, and my mom had to drop out of school because nobody would speak to her because she had a baby." I said it wasn't that easy, and it wasn't like fun and games. Some girls said that in my class, and so I went on this whole thing of like, no, you guys are all like, let's go to a baby shower, and then no one spoke to my mother, and she dropped out of school. So, and
Now I'm trying to think. Was it last year?
that was the year before, but it was last year's seniors because it was when they were in pre-calculus. The year before.
Well, I mean, our class is
But it wasn't that. It wasn't nearly as okay as it is now.
Yeah, weren't tons of shows about it.
Right. Both of those work. -1 we had to fill out because -1 minus 4. My grandma sent my mom to a home for pregnant teenagers when she was pregnant. There used to be, because you didn't want people to know that your child was a pregnant teenager. So she got sent to a home, and then finally she let her come home, but she brought my sister home. Like, my grandma brought my sister home from the hospital in like a paper garbage bag because she didn't want the neighbors to know that she was bringing the baby home. It's hardcore, right?
which one's this?
My older sister. I don't think they just like carried it like this. Like, I think they probably carried it nicely, I would guess. But then here's the best part.
Bread, I don't want to smash it.
My mom got pregnant again. Like, she had my sister when she was 16 and me when she was almost 19. Same dad. I don't know if it makes it any better, but it was the same dad. And she didn't want to tell my grandma because she didn't want to get sent back to a home for pregnant teenagers again. So she didn't tell anyone. Like, my mom never went to the doctor once with me, never had any prenatal care with me, never told anyone, waited until her mom went to work that night because she worked night shift. She was in labor all day with me and waited till my grandma went to work at 11 to go to the hospital because she didn't want her to know. And then when the hospital had a baby, and then the hospital called the hospital calls my grandma and says, she's here, she had a baby. So.
Do you just think your mom was like fat or something?
Well, because my grandma didn't want people to know she was pregnant, that my mom had to stay in the house all the time when she was pregnant with my sister, and she just gained a lot of weight, and then she didn't lose it all because she wasn't really allowed to leave the house very much because she was a 16-year-old with a baby. So, but she said she always just sit on the couch with a pillow over her stomach because when you're really pregnant, towards the end you can see your stomach move like if the baby's kicking. So she always just sit on the couch with a pillow over her stomach so that
Still,
no
you
one
live in the
would
same
know.
house, they wouldn't notice.
Didn't know.
Really? I mean, it's kind of easy.
Not a very. What do you think about that? It's no wonder I'm as screwed up as I am. I was born with extra finger also. 2 fingers, actually. I had 12 fingers when I was born. And I always blame my mom, and I always say it's because you didn't have any prenatal care. I have 12 fingers. But it's really not. It's just a genetic mutation. I always tell her it's her fault because she never went to the doctor. If you went to the doctor, I wouldn't have 12 fingers anymore. You learn a lot about me today. No, it's really not awesome. I was so paranoid my children were going to have extra fingers because it's just a genetic thing. But they didn't. No, it was really just like this awful thing. I mean, there's no pictures of it because obviously I don't think anyone's happy when their kid's born with 12 fingers. But there wasn't any bone in it, so think about that. Like, it's just like some skin hanging there. So they just clamped it off like they do with the umbilical cord. Like when they cut the umbilical cord, they just clamp it off so that it'll just dry up and fall off. So they just like clamped off both of them so that they would just dry up and fall off. But my sister pulled them off first, right? You know the story. She pulled one of them off.
Does it hurt? Like, do you even have like a bump or anything?
I do. On both fingers I have a bump. And I don't like to tell people the story, but then I just do. I just accepted it. But people will be like, "Oh, is that a wart on your hand?" And I'm like, "No, it's not a wart. I have 12 fingers." Why wouldn't I just say it's a wart? And then I don't have to explain that I have 12 fingers. It's a real problem. But I'm like, "No, it's not a wart." It is a good conversation starter. But it is a story. I put this on here because I was afraid we didn't do it earlier, but we did earlier. It was a harder one. How would you do this, Bob? Wait till Taylor listens to these notes. It's like my life.
Hey, now you know it's not right how you thought about it.
This is one you have two ways to solve it. You could rewrite it using the definition. So you could rewrite it doing what? You'd say 4 to the 2 equals x. How can I start with this one, right? That's it. That's the answer.
So there's another way.
That's the last one.
What? Or you can also 4 it. And you get x equals 4 squared, which is 16. Last one. Oh, goodness. When I was in college, the biology teacher talked about that, whatever it's called. It's some special name that's called when you have extra finger or toe. And after class, not in front of everyone, I told him that I had 12 fingers when I was born, and I showed him. And he wanted me to come around to all the other classes that he taught so that he could show them my fingers, like my nubbins, as we call them. And I said no. I'm a freshman in college, and I don't want to be known as a girl with 12 fingers. Like.
Give it like, well, give me a little bit of time.
Put that in first, right? Log 3 of x plus 4 squared. What can we do with this minus? What's that going to mean? Division. So if you see the stuff with the properties, put them back together first. Then what do you want to do? What?
I'm gonna make that minus 2. No, never mind.
Just 3 both.
We could 3 both sides, or we could rewrite it using the definition, right? If you have a log equal number, you can either 3 both sides, where the base is, or you could just say 3 to the second equals this, right?
But what if you just made it -2 and then you added 2 and then it's 0 and
No, you're making things up.
no, that's what I'm saying.
No, you can't add 2 and then subtract 2 and no.
No, I'm talking about like 40 divided by 9.
Like subtract 3 to the other side.
No, no, no! That's multiplication. You
No,
can't.
on the other side.
What?
Imagine we're gonna figure it is 9.
Oh, I see what you're saying.
So then really,
He's saying that this is really just 2. Log 3 of 9 is just 2. So he's saying that that's minus 2 equals 2. So then
that would be -4 later.
it wouldn't be 0, but it would be 4. That would be log 3 of x plus 4 squared equals 4.
That feels like it.
So then 3 to the... Quick question, why couldn't you just write it 2 both? When
That's
you
what I
just brought it up.
Because you can't, if you divide this by 2, you have to divide this by 2 also.
Right?
Oh, why wouldn't I just divide by 2 there?
Yeah, once you got the 4, instead of making
Yeah. You could divide by 2. There's so many ways you could do this problem. I know, I like my way. I'm afraid these aren't going to be the same answer, though.
So you know, you just gotta.
I swear.
2 squared.
Just kidding.
So then I'm going to multiply both sides by 9 and get x plus 4 equals 81. And then we can just square root both sides, right? Like we could FOIL this out, but I think the best option here would be to just square root both sides. It's like a little completing the square already completed for us. And you get x plus 4 equals plus or minus 9. Subtract 4 over, and you get x equals 9 minus 4, or x equals negative 9 minus 4. Nathan, I don't think that worked your way. I need to look at that closer. Like, I don't think you get the same answers, do you? Like I'm just
following your steps because I was lost. Goes off a my little way, and then you exit all out.
I know I don't like your way. I think it's wrong, but it seems like a good idea. Do both of those work? Did you get 9 and negative 13 in your crazy way?
I didn't finish it because
Oh.
it's like
Yeah, but if it's both sides, that's why you do.
Oh yeah, I forgot I was at the 3 both sides still. You're good. I think negative 13 does not work, so 5 is the only answer. Just a bunch of algebra today. Tomorrow we'll do more LN and E stuff. Here's the homework. Not even that many problems. 6 through 30 multiples of 3. 9 problems. Some of them are pretty easy. We'll look at them tomorrow. And tomorrow will officially be our last day of new stuff. But